Hello? Hmm. Okay, so good morning, everyone. Let's start our class today. Okay, so as I said last week, this week will be a revision class. Okay, and today's lecture will cover like 70 or 80% of the content that will be examined in the next week quiz. Okay, so the other 20% to 30% might from the lab exercises. Okay, there's some typos here. Okay, what I mean lab exercises. So if you, for example, if you pick like any kind of tutorial of the lab, okay, you have a section of exercises, right? So I mean, like in the quiz, I might pick some exercises from the labs. Okay, so you might need to have a look in the exercises. Okay, so yeah, let's go ahead. So I mean, if you just have a revision on the slides here, then you'll get like 70 to 80% in your quiz, okay? Okay, so, and after today's revision class, we will have a Kahoot test, okay? So I've prepared some gift for you. Okay, so there are in total like 4 prizes. So for the first prize that if your quiz, I mean for no, sorry. For the first prize, yeah. If your quiz score is over 85, I mean your quiz score in the last week, okay, not in the Kahoot. If your quiz score is over 85, then you can use this card to get 5 extra scores. Okay. And if you got more than 95, then the overflow scores will be added to your final project. Okay. So I mean, if you got 100 in your upcoming midterm exam, and also you get the first prize here, then you will have like 5 extra scores in your OES project. Okay. And then for the second prize, you have 10 extra scores in your quiz. Okay. If your quiz is between 40 to 84. Okay, so we'll have 10 prizes here. In total, I will give you like 65 cards. Okay, the cards is something like this. So I'm not sure if this like scratch the translation is correct. Okay, I call it scratch off card. So in total we will have 65 cards. And we will have 20 prices. How much? 25 prices. Okay. And 5 prices is for the first prize. And there are 5 extra prizes for first prize. That is for the top 5 students who got the top 5 scores in the Kahoot test. Okay. And then for the second prize, we will have 10 students. Okay. And then for the third prize, we have 5 students. And this prize is used for students who might be afraid that he or she will fail in the exam. Okay, so if you got like 20 to 39, then you can use this card to set directly your score to 40. Okay. And there are also 5 special prizes. So it's PopMat, Labubu, the monster figures. Okay, something like this. I put here. We have some figures, something like this. Okay. And this we have 5 prizes here. So there are also some instructions I've put here. Okay, so if you got top 5 in the Kahoot test, you will get the prize 1 here, and also 3 scratch-off cards. Okay, and if you're top 10 in the Kahoot test, you'll get 3 cards. Okay, and if you're top 20, you'll get 2 cards, and also doesn't matter if you are beyond 20, you will still have a chance to get 2 cards. Okay, but I think in total, do we have 20 students here? I think it's just 20. So everyone will get the cards. Okay. So that's good. Okay. Okay, then let's start our revision. Okay, but I think there was some problem with the font here. I don't know what happened. I think the version in your PDF is correct. The PDF version should be correct. Yeah, your PDF version, the font is correct. I think the decoding of the font here, maybe the system is a bit different. Okay, but it doesn't matter, okay? So let's start from Unit 1. Okay, so very beginning, the first class, what we learned is parallelism and concurrency. Okay, so you need to know the difference between parallelism, concurrency, and sequential execution. Okay. So for sequential execution, tasks running in 1 by 1. Okay. So if you only have 1 CPU, and you run your first task first and then your second task. So it is called a sequential execution. And parallelism means multiple tasks running at the same time. Okay, so you have multiple CPUs, or at least you have more than 1 cores of CPUs. Okay. And then the 2 tasks will be running on 2 different CPUs in a parallel way. And it's called parallel execution. Okay. And then we also have concurrency. So concurrency means multiple tasks running in an interleaved way. Okay. So we run some part of the task 1 and then some part of task 2 and then again some part of task 1 and then some part of task 2. So for a concurrent task, it can also be on a single CPU. Okay, but we need to do something called context switch. Okay, and one thing that you need to pay attention here is that the parallelism is a special case of concurrency. Okay. That's why our course is called concurrent programming, right? Although we also taught about parallelism, but parallelism is a part of concurrency. That's why the course is called concurrent and network programming. We didn't say about parallelism, okay? Because parallelism is already included in concurrency. And then the second part is CPU bound task and IO bound tasks. Okay, you need to have a clear idea about what is CPU bound task and what is IO bound tasks. What's the difference between them? So CPU bound task, okay, actually just like more about computation, okay, because CPU is used for computation. So if the task spend most of time in the in the computation, then it is called a CPU bound tasks. Okay, so it involved complex calculations. And if you have faster or better CPUs, then the task will be finished faster. Okay. And IO bound tasks spend most time in doing IO, input and output. Okay. Such as your networking, or you read or writing storage devices. That's all about IO, okay, input and output. And one important thing here is that for one task, it doesn't mean that you only have computation or only have IO, okay? So for a CPU bound task, you also have IO operations, okay? But what I mean CPU bound task here is that most of the time that you spend on this task is about computation, then it is CPU bound tasks. And if most of time you are doing IO, then it's IO bound tasks. Okay. So for IO bound tasks, you also have some computations. Okay. And another point here is that if we have multiple IO bound tasks, okay, we can use proper multitasking to increase the efficiency of the tasks. Okay, this one, I think you can refer to the previous slides. Okay, I'm not going to talk about details, but you can refer to the slides in lecture 1. Okay. Okay, the next point is about processes. Okay, we've talked about processes and threads. What happened to the fonts here? Okay, we have processes and threads. Okay, then you need to know the concept of processes. Okay, so very simple. A process is just an execution of the program. So in a process, it presents the states, especially the variables, okay, of the execution at the runtime. And you need to know that a process can create another process. Okay. So you have multiple processes, and maybe at the beginning you only have one process. And this is called a parent process. And a parent process, it can create another process and run in another CPU or CPU cores. And if you have multiple processes, they do not share the memory space. Okay. So this is the important thing in processes. No matter how many processes you have, they don't share any memory spaces. But how they communicate? Because you might still need to do some communication between different processes. Okay. For communication, the processes, they send messages. Okay. Or they send messages between processes, or they use some OS level shared memory. Okay. If you still remember that we talked in the later lectures, I think it was in lecture 6, maybe. So we've created some special memories for multiple processing tasking, right? Because they don't share memories. So we need to manually create some memory space for them. Okay. If we want them to share some variables. And you need to know about the advantages and disadvantages, or we see the pros and cons of the processes. Okay. So because parallel processes, they do not share any memory space. Okay, so they don't interfere with each other. This is one advantage. Okay. And the disadvantage is that because processes have their own memory spaces. I mean, they don't share memory spaces, but they have their individual memory spaces. So every time you create a process, you need to create a memory space for them. Or we say we need to allocate memory spaces for them. So this allocation of memory space is a bit slow. Okay, that's why the creation of processes will be slow. And then we need to do some context switch between processes. If we want to execute one processes to another processes, okay? I mean, if we want to switch from one process to another, we also need to do some context switch, okay? Because we don't share the memory space. That's why we need to do some context switch, okay? And then this will cause some overhead of saving the state and changing the CPU execution mode. Okay, so we have some overhead in multiple processes tasking. Okay, so these are the one advantage and two disadvantage of processes. I mean, for multiple processes. Okay, and then we've talked about threads. So threads is created inside processes. Okay, so we can see that threads are flow of execution unit inside a process. And the difference between thread and process is that threads, they share the system resources owned by processes. Okay, so you might have one single processes, and inside these processes, you have several threads inside. And these, for example, 3 threads here, they share the system resources. They share the memory spaces owned by the process. Okay, and the process might start with one thread at the beginning, and then it can create more threads in its lifespan. Okay, depends on how many threads you need. Okay, so what's the advantage and disadvantage of threads? So threads, because it shares the system resources of the process. That's why if you want to create a thread, it is much faster than creating a process, because it doesn't need to allocate memory space or other resources. It directly uses the resources from the process. Okay. And switching threads within a process is more efficient than switching processes. Okay, so it's easy to understand because all the threads, they use the same resources. So if you switch from one thread to another, you don't need to change any other memory spaces or resources. So it's much faster or efficient than switching between processes. Okay, and also because the threads, they share the same resources, so they can communicate efficiently. Okay, because all the shared variables, they are inside the same processes. They are inside the same memory space. So they can communicate in a very efficient way. You don't need to create new or extra spaces for the variables. Okay. Also, you have more efficient than the message between processes. Okay. And a disadvantage of thread is that we need to do synchronization if we want to access to a shared data. Okay. Because later we've talked about race condition, right? When we're talking about synchronization. So if some threads, they want to access to some critical section of the code where they have a shared data inside that section, then if this kind of operation is not atomic, then it will have some risk condition, and then the result might be uncertain. Okay, that's why we need to do synchronization between threads. Okay. Yeah, and here is a comparison between threads and processes. Okay, so we know that threads is lightweight because they use the resources from processes, and processes is heavyweight, okay, because they have their individual resources. So thread is efficient to create, we already talked, okay. It's also more efficient to terminate, communicate, and switch context. In comparison, processes is inefficient to create or terminate or communicate or switch between different processes. Okay, and threads, they demand less resources, okay, because they share the same resources. And then processes, they demand more resources. They have their individual resources. Okay. Yeah, so threads, they have shared memory, and processes, they do not share memory between each other. And threads, they require synchronization for accessing shared data. And processes, they don't have any shared data. But actually, processes, if we are doing multi-processing tasks, we still need to do synchronization, right? Okay, so yeah, so as we've just mentioned synchronization. Now we are going to talk about synchronization. Okay. So what is the use of synchronization? And why we need synchronization? Because concurrent execution of multiple processes. Here's something I forgot. Maybe processes or threads, okay? Not just in processes, also in multi-threads. Okay, so if a concurrent execution of multiple processes and multiple threads is done in a non-deterministic order, it will be problematic. Okay. So why we say like concurrent execution of multiple processes or threads might be done in a deterministic order? Why? I think you yeah, I'd like to mention about, I think you might be very familiar, but if you still remember about I think in lecture 3, yeah. There are some slides about problems of interleaving operations, right? So we say if an operation is non-atomic, okay, non-atomic, which means this operation might involve multiple steps, okay, then these steps in different threads, okay, you don't know which thread execute which step first. So here is an example, right, about doing deposit to your bank account. So if you have two operations of deposit in two different threads or processes, you might have different outcomes depending on how different the order it is. Okay. So this means that if your operation is non-atomic, then your result is also not deterministic. Okay, so sometimes in this case, sometimes your balance in the end gets 220 and sometimes your balance 170. according to different execution of the order of the steps. Okay, so that's why we say if the execution is done in a non-deterministic order, it will cause some problem in the result. Okay, so we need to do synchronization. So synchronization means to coordinating the execution of processes or threads to ensure a correct outcome or a deterministic outcome. Okay. And if we don't do proper synchronization between threads or processes, what problems we will have? We will have race condition, starvation, or deadlock. Okay. So I think this race condition and deadlock we've mentioned during our classes, okay, in some other individual slides, other lectures. We especially talked about race condition and deadlock, but we didn't talk about starvation, okay? But here we can still have a revision about what the concept of these three things or about the three problems. So we say a race condition is a situation in which the outcome depends in the order of the concurrent execution. Okay, so it means two different threads, they have a race condition in doing something. Okay, so you don't know who will do this task first. Okay. So it's just like you want to, you are going to reach out something. Okay. So your friend is also going to get the same thing. So you have a race between you and your friend. And you don't know what will be the result of the race. Okay, that's called a race condition. And starvation happens when a process is kept waiting for resources, which will be never available. Okay. So it's like some resources will be held by some other threads or processes forever. And then you allocate that resources also to another thread or process. So that process will be kept waiting for the resources. But that resources is already being occupied by some other threads. And it will be occupied by that thread or process forever during the program. So this causes a starvation. Okay. And also we have deadlock. Okay. I think you are very familiar with deadlock because we've give you many examples. If you still remember about the dining philosopher problem, we talked in details about how deadlock happens. Okay, so deadlock happens when multiple processes are waiting for resources that are held by some other processes, so no process can proceed. Okay, so it's like, we will talk about details later. Okay. Okay. Then to avoid these three different problems, we've introduced the idea of critical section and mutual exclusion. So you need to know about the concept of critical section and mutual exclusion. Okay. So what is a critical section? So it's just a piece of code in a process that access a shared resources. Okay. Here also not just processing, it can also be threads. Okay. It can be a piece of code in a process or threads. Okay, that access a shared resource. Okay. So for this critical section, it should finish execution before another process can access the resources. Okay, and also it should not be preempted or interrupted in the middle. Okay. So that's why to ensure these two things here, we need to do mutual exclusion. Okay. So mutual exclusion means that at most one process can be in its critical section at a time. Okay. So what I mean is that only one process is allowed to access the results. So here, for these things here, okay, when we're talking about processes, we also talk about these threads, okay? It's not just for process, also for threads. Okay. So how we deal with this critical section problem? We need to careful design of synchronization. Okay, we've just talked about it. To cooperate and ensure mutual exclusion. So what we have for the solutions is that we have logs, right? We've talked in the previous lectures, semaphores and monitor, okay? Monitor we've mentioned, but we are not going to examine, okay? Monitor is not going to be examined. We only examine logs and semaphores. These two concepts is more important, okay? Yeah, so let's talk about some more details about logs and semaphores. So you need to know about what is log and what is semaphores. So they are both used to control the access to a shared resources or a critical section, okay? Among the multiple threads or processes to ensure mutual exclusion. Okay, so they are designed to control the access to a shared resources to ensure mutual exclusion. Okay, what's the difference is that a log only have a value of 0 and 1, but a semaphore, it is an integer variable used to control the access to a shared memory. Okay, it is an integer variable. So it can be any value, okay? It can be 1, 0, 1, 2, 3, 4. Once it's an integer, it can be used as a semaphore, okay? And then there are two kinds of semaphores. One is a general semaphore, or we say a counting semaphores. So it can have any values. And another is a binary semaphore, okay? And then it only have a value of 0 and 1. So for a binary semaphore, it actually has almost the same function as log, okay? So sometimes we also use a binary semaphore as a log, okay? And for the general semaphore, the integer stands for the amount of the resources available, okay? So this we've give you examples in this buffer and also the dining philosopher problems, right? And then you also need to know how the log works. Okay, there's a diagram about how the log works. So if, for example, if we have two threads, okay, we have a log. So the first threads will try to access or acquire the key to the log. Okay, so if it is able to get the key to the log, it will go inside the room, okay, to use the resources. And then it will take the key together with him when he is using the resources. So the other threads will not be able to get the key to the log, and they will wait outside, okay, until the first thread finish the task. Then the second thread will use the same resources later. Okay, this is the main idea about how the log works. And then we've talked about this consumer and producer and consumer problem as an example for the semaphores, right? So I'm not going to talk about the details here. You can have a look by yourself. Okay. So what we need to know is that we have three potential synchronization issues in this producer and consumer problem. Okay. The first one is that they might have concurrent access to the buffer. Okay. And then they might write to the buffer when the buffer is full. They still keep writing things, data in the buffer. So this is also a problem. Okay, another problem is that the consumer might keep reading from the buffer when the buffer is already empty. It's still trying to get data from the buffer. Okay, this is another problem. So to prevent these problems, we need to define semaphores in this procedure. Okay, three different semaphores. We need to use three different semaphores. One semaphores represent for the access. Another semaphore represent for the uh how to say to another semaphore is used to indicate if the buffer is empty or full. Okay, another two is used to indicate if the buffer is empty or full. Okay. Yeah, and after that, we've talked about deadlock. Okay. So deadlock is the situation that multiple processes or threads are waiting for resources that are held by some other processes and in such a way that no process can proceed. So it's like this. Okay, resource one is held by by process one, and then process two is trying to request resource one, but this resource one is already held by process one. So process two can also not be executed. Okay, and resources two is held by process two. So process three can also not be executed because he needs some resources from resource two. Okay, so in this way, none of the process is able to be executed because all the requested resources is held by another process. Okay, and then we have four necessary conditions to form up a deadlock. Okay, so this is four necessary conditions. You can have a look by yourself. So among these four conditions, we can find solutions. We can find solutions in only in these two conditions. Okay. So what I mean is that if we want to prevent deadlock, we need to prevent hold and wait state, or we need to prevent circular wait. Okay. We need to prevent these two conditions to prevent a deadlock. But we cannot do anything in this mutual exclusion and no preemption. Okay. Because this mutual exclusion is necessary. Okay. We cannot break mutual exclusion. And also, no preemption is the main concept of the system execution. Okay. So we can also not preempt the execution of some threads or process in the middle. Okay. So this is a basic requirements of the system, which is no preemption. So we can only do something in these two conditions, which is red here. Okay. Then we've talked about this learning philosophy problem. Dining, sorry, dining philosophy problem. Dining philosopher's problem. Okay. So I'm not talking about the details about this problem. Okay. You can have a look in the slides or the previous lectures. Okay. So what you need to know is the solutions to prevent deadlock in this problem. So I've given you example of three different solutions. Okay. And two of them is used to prevent circular wait, and another of them is used to prevent hold and wait. Okay. You can have a look by yourself later. And then we've talked about resource pooling. Okay. So why we need to use resource pooling? Okay, we maintain a pool of expensive resources. So we don't want to create new resources every time we want to use it. we just create at the beginning. And then if we finish the use of it, we don't need to delete it. Okay, we give it back to the resource pool. So we can save the time of creation and destroy. Okay. So here is a comparison between no polling and polling. Okay. So if we are not using resource polling, then every time we create resources for application, and after the application, we destroy it. And if we have resource pooling, every time we borrow from the resource pool, and after the application, we return it to the resource pool. So the resources is still there. Okay. So in this case, when we are talking about resources, we mainly talk about threads and the processes. Okay. In this case, we mainly talk about thread and processes. So which means every time we borrow threads or processes from the resource pool, and after we use these threads and processes, we give the threads and process back to the pool. Okay. And then we will have some advantage and disadvantage of resource pooling. So of course, we'll have better performance by using the resources because we avoid repeated creation of different resources. And then we have a centralized control of resources because we put all the resources in a pool. Okay, so we manage them together. So we have a centralized control. Okay, and because we have a resource pool, so every time we just borrow and return the threads and processes from the resource pool. So we have a convenient interface to use the resources. Okay. And there are two disadvantages. So one is that we will need to, we will have some extra overhead of managing resources in the pool. Okay. And then if we pre-allocated some resources, we might cause some waste of these resources if we don't need that much number of resources. Okay. So for example, sometimes you only need to have like 5 threads in your program. But at the beginning, because you don't know how many threads you need in the future. So at the beginning, you create maybe 10 threads. Okay. But actually your program only need to use 5 threads. Then you'll waste 5 threads in your resources pool. Okay. So this is a risk of waste of pre-allocated resources. Okay. Then here to the slide 15, we finished about concurrent programming, right? Then we've talked about the networking. Okay. We've talked about networking. And in the very beginning, we've talked about the Internet Protocol Suite, the IP. Okay. So we said like, if we want to communicate between different devices, like between Android or iOS devices, we need to have some standards. Okay. That's why we have a standard structure which has 4 layers. Okay. Application layer, transport layer, network layer, and physical layers. And in our course, we only talked about application, transport, and network. Right? Actually, we've already talked about 3 things here. We've talked about IP, the transport method, TCP, UDP, and also we've talked about HTTP in the last week, right? About web application. So we covered these 3 layers in our course, but not the physical layers, okay? And here's the idea about something is called encapsulation. Okay, it just means a layer uses the service provided by the layer below. So application layer is using the services from the transport layer. Okay, and the transport layer is using the services from network layer. That's it. And then we've talked about different IP versions. Okay, we talked about the IP and the IP versions. So you need to know what is IP. Okay, so I think you know about IP address, right? The protocol used to address host in a network and to route packet among the host. This is called IP. Okay, simply just give some address to the host. Okay, for transportation. And then we have two versions of IP, IPv4 and IPv6. Okay, and the limitation of IPv4 is that it has a very limited number of address that it can be created. Okay, so it is not enough. The address will not be enough for all the devices in the world. Okay, that's why later we introduced IPv6. Okay, IPv6 have 122 bits, and IPv4 only have 32 bits. So IPv6, it can generate much more addresses than IPv4. Okay, so it address, I always say it resolved the major limitation of IPv4. Then we've talked about TCP and UDP, okay, right? TCP and UDP. Okay, maybe I directly use the one in that I upload in the OLE. Okay, we've talked about TCP and UDP, right? So what you need to know is that TCP is a connection-oriented protocol, and UDP is a connectionless protocol. Okay, so what's the difference? The difference that TCP is more reliable but slower, and UDP is not that reliable than TCP, but it's faster. Okay, so in details, we say that TCP guaranteeing end-to-end delivery and sequencing. Okay, so to guaranteeing this end-to-end delivery, we use checksum, acknowledgement, and retransmission mechanism. We have three different mechanisms here. Okay, and here are the functions of this mechanism. Okay, you can have a look by yourself. And then for UDP, we transmit data using independent packet, which is called datagrams. Okay, so we don't have any mechanism of retransmission or resequencing of data. Okay. So in this way, because we don't need to establish a connection between client and server, so UDP has less overhead and has higher transmission rate. Okay, this is the advantage of UDP. The disadvantage of UDP is that it has no guarantee of data correctness or order of received data. Okay, so sometimes because you break the data into different packets, and some packets at the beginning might have some delay. So the middle packets might arrive faster than the beginning packets. Okay, then the order will be changed. Okay, so that's why in UDP, it doesn't guarantee the correctness of the data or the order of the received data. The order might be changed. Okay. So we've talked about some suitable applications of UDP, especially in some real-time apps, which prefer quality degradation to delays. Okay, so I mean, in these kind of real-time applications, the speed is more important. Then we need to use UDP. Okay, for example, like streaming video or online gaming. Okay, you cannot bear any delays for the video and the gaming, right? So you need to use UDP. And like for file if you want like transmit some files, okay, or some document, then you might need to use TCP, okay, because you don't want to lose any data in the document. Okay, that's it. And another thing is that UDP support multicast applications. Okay, because it doesn't need a certain connection between the client and server. So this server or client, actually the server, it can send information to multiple clients, okay, because it doesn't need a certain connection. So it can send the data to multiple clients in the same time. Okay, that's why we say UDP support multicasting, okay. And then you also need to know some difference between TCP and UDP programming, okay. So we have TCP server, UDP server. What's the difference between the programming? Like what kind of method we need to use in TCP, but we don't need to use in UDP, okay? This you need to know. And then we've talked about the software logging, right? Yeah, we've talked about the Python logger, the Python logging module, and we've talked about the severity level of different event for messages. Okay, there are like 5 severity levels, which is debug, information, warning, error, and critical level message. Okay. So the number here is the severity of the event. Okay. You can have a look. And one thing is here that a logger is associated with a severity level and logs messages of that associated level or higher. Okay, so you can associate the logger to a level of event, and then this logger only logs messages of that associated level or higher levels. Okay, and then closely we've talked about web server and web applications. Okay. Then you need to know about the difference between web server and the web applications. Okay, so the main difference is that the web server serves static content in storage, and web application, it serves dynamic content tailored for clients, customized content, okay, according to the maybe database. Okay, you need to know the difference between server and application, web server and web application. Then we've talked about routing in this web application. Okay, you need to know what is a view function. Okay, and how we do this routing. We use the method called route. Okay, we use this route method to bind the URL with the function, which is called a view function. So what is a view function? You need to know that view function is a Python function that receives a web request and returns a web response. Actually, it just contains the logic for processing the request. So this is called a view function in web application. Okay, and then we write things in this way, right? alt-app.route. We use the route method here with a URL here. So this is called a decorator. Okay, and if we use a decorator to decorate a view function, then this view function will be called as a decorated function. Okay, it is enhanced with routing information, use a decorator. Okay, and then we've talked about the template. Yeah, the last slides, we've talked about templates in web applications. So you need to know why we need to use a template and what is a template. Okay, so actually templates is just HTML plus placeholders plus logic. So it is a reusable blueprint for generating dynamic web pages. Okay, why it can be dynamic? Because you have some placeholder, some variables in your template. Okay, and then it provides cleaner and maintainable code. Okay, and we also might have some logics for flow control in the HTML. Sorry, in the template. Okay. Okay, that's it. So here are all the things that we are going to, not all the things, I said like 80%, okay, of the content of the exam. So if you just want to pass this exam, then I think if you can just refer to these slides, okay? If you just want to pass the exam, these slides is already enough for you. And if you want to get better scores, you might have a look at the exercises in the lab question papers. Okay. Okay, so I'll give you, I think, yeah, I'll give you like 5 minutes break and then we will have our Kahoot test. Okay. Oh, and this week we will not have a lab assignment. Okay. So the labs this week will be QA sessions. Okay. If you have any questions, you can come to the lab to ask me. Okay. And if you, the attendance is not necessary. Okay. So if you have any questions, you can come to lab. And if you don't have questions and you want to revise by yourself, then you don't need to come. Okay. This week, like the next lab at 11 o'clock and also the one tomorrow. Okay. So I'll be there. And if you have any questions, you can come. And if you don't have questions, you don't need to come. Okay. You can revise by yourself. And we don't have any assignment this week. Okay. Okay. Okay, so we will start the Kahoot test at 5 after 10. Okay. Okay, so let's start the Kahoot test. Start. So you can scan the QR code or use the game pin here to join. Oh, and it's not necessary to use your student ID here because you need to write your ID on the cards later, okay? Okay. So I think everyone have joined, right? Someone need more time? Okay. One more minutes. Okay. So let's start. Yeah, so parallelism always require multiple CPUs, okay? Because you need to run two tasks in the same time, okay? So you need to have multiple CPUs or at least multiple cores, okay? What is that? Okay. Congratulations, Trump. Please don't fuck up that stock, okay? Okay, the second question. Okay, yeah. So the main feature, TCP's main feature is connection oriented. Okay, very simple. Connectionless is the UDP, okay? Brilliant. Yeah, CPU bound task. Uh, yeah. Okay, this one I will say that you are correct. Okay. Okay. Hmm. No, a big change. Trump disappeared. The first one. This is a multi-select question. Okay. Yeah. So as I said, there are here we have two functions. So for semaphore, it can be a binary or a general or counting semaphores, right? So it can indicate the amount of available resources, and also it can be used as a mutual exclusion. Okay. Mm, very easy question. Yeah. It doesn't have sequencing or retransmission. Okay, and also it's connectionless, but it support multicast. Okay. Mm. Yeah, it's B and C. Okay. So mutual exclusion is the thing that we need to do, so we cannot prevent it. Okay, and preemption is the nature of the system, so we can also not do anything on it. What we can do is to prevent circular weight and hold and weight. Mm. Yeah, very good. Most of you get the correct answer. Okay, video encoding and compression, it's more about computation. Okay, it's convert the video to another kind of coding format. Okay. We have how many? 5, 6, 7, 8, 8 questions left. So for the exam, I will pick some questions from the Kaggle test. Okay, so later you will please have a revision on the Kaggle test. Yeah, very good. So as I said, threads are lightweight and processes are heavyweight. Okay, because threads, they shared the resources from the processes. Okay, and process, they have individual resources, so they are heavier. Okay. Very fast this time. Yeah, this is the disadvantage of resource pooling. Okay, and centralized control of resources, this is the advantage. Okay, performance, it will be better. Okay, if we reuse resources, the performance will be better. We avoid repeating creation of the resource again and again. Okay, and also we manage the resources in a resource pool, so we have a better interface to use the resources. It will be more convenient. Okay. Mm. You need to order it from the most severe to the least severe. Okay. Yeah, from critical error warning information. I don't know what kind of mistake you can make here. Okay. Okay, but yeah. Three in a row. Congratulations. Yeah, I've mentioned many times during this Kahoot test. Okay. Processes, they don't share memory space with other processes. Hmm. Last four questions. Yeah. Who choose the mailbox? I mean, yeah, the IP is used to address the host, okay? So I mean, during the lecture, I said like it is similar with a mailbox, but it is not a mailbox, okay? Yeah, it provides the address for the host, okay? Uh, and most of you are correct. Okay, to process web requests, it's a logic to process web requested. Sorry, web request. Okay, and A, it must be decorated. It is not correct. Okay, view function can be not decorated. If it is decorated, we call it decorated function. Okay, but it doesn't mean that all the view function must be decorated. Okay. And then B and D, I think is very simple, right? It is D, okay? So what I said here is to prevent circular weight, okay? So we need to limit the concurrent philosopher to it, okay? So if there are 5 philosophers and only, if we limit that only 4 they can eat together, okay? Then we prevent the circular weight, okay? And C, like if you say like philosopher use the same chopsticks in the same time, okay, it is a bit disgusting, okay? It's cause a risk condition, right? And of course they cannot use the same chopsticks in the same time. Okay, multi-select. Please pay attention, it's not used in UDP programming, okay? Yeah, it's E and D because we don't need to establish a connection between the server and the client. So we don't need to keep the server listening and connect the client to the server. Okay. We only use receive from and send to. Okay, last question. Then this question doesn't have score. Okay. Okay. Yeah, very good. Just for fun. Okay. Uh, at least only 15% that won't give me some color to CC. Okay. Okay. Yeah, but anyhow, I will be in the quiz. Okay. So this is not just not a good hope. Okay, then let's see the result. Yeah, congratulations, Winnie. 508 and 291. Okay, congratulations. And okay, the result is session summary. Beautiful report. Okay, and participants. Yeah, then we have a rank here. Oh, very good. 93% accuracy. So who is 291? Oh, very good. Congratulations. So you have I wish you the okay. So you have 3 cards, okay, and you get this price 1 by default. Okay, you have 5 scores in the upcoming exam. And then please just raise your hand for the top 5 students here. 508, Winnie 440, and 805. Okay. Great. From 11 to 20. 11 to 20, you will get 2 cards, right? Yeah. 11 to 20. Please raise your hand. I will give you. Okay, then we will have a lucky draw for 10 students. We will have from 21 to 44. (21 to 44). Okay. 23. This guy. 39. Bruce. 28. T Sam. 42. Peter. Peter here. Peter. Okay, last one. Last one. 34. Oh, lucky. Mike. Mike. Mike still here? See, right? Huh? You have two. Oh, you have two. Okay. Then we use another one. 29. Who is this guy? 5481. 5481. 54. You You mean you already get bonus? Yeah, okay. 546, 5481, not here. And this already have. 28 already have, right? T7 years. 34. IEE. I. Is there any people that we got 3 cards, but we got all dents? 有没有人3张都吃的机会会过啊？还有人吗？Okay, so please, if you got price 1, price 2, price 3, please write your ID and your name on the card and return to me, okay? And if you got thanks, then just bring back home, okay? 你是义务卡吗？太黑了，应该是25、65分之25的概率不当，就是25个奖，然后65，总共65张数。Okay, and who get this special prize? I mean, I've written numbers there, right? So number 1 means prize 1, number 2 means prize 2, number 3 means prize 3, okay? And if you have 4 prize, then you can give your card to your friend, okay? Doesn't matter. I only check what you've written on the card, okay? Please write your ID and your name, and then return to me, okay? 你把那个名字学校写在卡上，然后还给我，我要去登记一下的。然后谁是拿的那个 special 的？special 的就你，不可能就你一个，5个。special 自己上来拿下奖吧。对吗？这2个 special。就前面这个，你得写上去。要吗？不用。名字也写的写上。有2个去，你可以给朋友或者7张写，那还是多或者那学会也行吧，学会也挺好。可以。If I have prize 1 and I also have prize 2, then you can use both. No, it depends on your interval. Yeah. So think about, let's say if I try 90, if I drop to 90, then price 2 is. Yeah. Okay. This is that you'll get 10 extra scores if you got. So here is like the meaning of your score, okay? Okay. Write your name, right? Okay. Your name, price, okay. 这2，对。哦，可以接受。Both of them get special.
Yeah.
2. Okay, but you can only use one. Okay. You can give one to your friend if you want. Okay. Okay. Okay, thanks. Very good. 然后这周那个实验课没有作业啊，那个实验课是那个解答啊，然后你们有问题的可以过来，没问题不过来也行啊，就没有签到。Any students? Okay.
那个就是面积低是吧？全是 MT 是吧？
没有2个，有50%的 MC， 还有50%的 self question。
就那个整个题是50，然后考察题
简单题
没有辩证题，
没有，他我可能会问你一些变数有关的问题，就可能给你一个代码，问你这个代码是干什么用的，
OK，
不会让你写代码。
刚才那个测试的，
对。
那还有个就是就是好的话就是刚才那个知识。
对，就是 Unit 1到8的。
是不是就是你那个刚才放的那其中复习的那个？
对，
就重点是那些，然后可能有些别的在。
对，这个基本占80%。
哦，然后剩下的我们就是20-30在那个实验。
对，
那个课件你记有干啥？
对，可能有一些对。
要
练习还没过来。写下学号好了。2。Who got prize 1？每个拿一个。
录完。
怎么可能？
送回去。哎，老师送回去。
你都是3个吗
？4个人。
啊？你们什么都没拿到吗？
我有第2名。啥都没拿到。4个人全部都是感谢。
那 prize 1呢？
反正差不多。
没有 price one。
有呀。
啊？
写了个 1的，写了个1的。
没有啊，回家了。
哎，没有放进去，没了。
怎么没有了？
没了。
不会当成那个没看见 prize 当成是那个。OK。那 prize 3怎么也没有啊？
我想要 prize B 也可以送我一个 prize B 吗？
啊，
这样该挺贵。
等一下。
我们有10张，我们有20张 thank you。
No。耶？